And it's by looking at the pattern of genetic variation, the pattern of these markers in people all over the world, and assessing the relative ages when they occurred throughout our history, that we've been able to construct a family tree for everybody alive today. Everybody in this room, everybody in the world, falls into a lineage somewhere on these trees. Now, even though these are simplified versions of the real trees, they're still kind of complicated, so let's simplify them, turn them on their sides, combine them so that they look like a tree with the root at the bottom and the branches going up. What's the take-home message? Well, the thing that jumps out at you first is that the deepest lineages in our family trees are found within Africa, among Africans. That means that Africans have been accumulating this mutational diversity for longer. And what that means is that we originated in Africa. It's written in our DNA. Every piece of DNA we look at has greater diversity within Africa than outside of Africa. And at some point in the past, a subgroup of Africans left the African continent to go out and populate the rest of the world. Now, how recently do we share this ancestry? Was it millions of years ago? Which we might suspect by looking at all this incredible variation around the world. No, the DNA tells a story that's very clear. Within the last 200,000 years, we all share an ancestor, a single person, mitochondrial Eve, you might have heard about her, in Africa. An African woman who gave rise to all the mitochondrial diversity in the world today. But what's even more amazing is that if you look at the Y chromosome side, the male side of the story, the Y chromosome Adam only lived around 60,000 years ago. That's only about 2,000 human generations, the blink of an eye in an evolutionary sense. That tells us we were all still living in Africa at that time. This was an African man who gave rise to all the Y chromosome diversity around the world. It's only within the last 60,000 years that we have started to generate this incredible diversity we see around the world. Such an amazing story. We're all effectively part of an extended African family. Now, that seems so recent. Why didn't we start to leave earlier? Why was it that we seem to have come out of Africa so recently? Well, that's a big question. These why questions, particularly in genetics and the study of history in general, are always the big ones, the ones that are tough to answer. And so, when all else fails, talk about the weather. What was going on to the world's weather around 60,000 years ago? Well, we were going into the worst part of the last ice age. But basically, from 70,000 years on, things were getting really tough, getting very cold. The northern hemisphere had massive growing ice sheets. New York City, Chicago, Seattle, all under a sheet of ice, most of Britain, all of Scandinavia, covered by ice several kilometers thick. Now, Africa is the most tropical continent on the planet. About 85% of it lies between Cancer and Capricorn. Rather, Africa was drying out at that time. This is a paleoclimatological map of what Africa looked like between 60 and 70,000 years ago, reconstructed from all these pieces of evidence that I mentioned before. The reason for that is that ice actually sucks moisture out of the atmosphere. If you think about Antarctica, it's technically a desert. It gets so little precipitation. So the whole world was drying out. The sea levels were dropping. And Africa was turning to desert. The Sahara was much bigger then than it is now. And the human habitat was reduced to just a few small pockets compared to what we have today. The evidence from genetic data is that the human population around this time, roughly 70,000 years ago, crashed to fewer than 2,000 individuals. We nearly went extinct. We were hanging on by our fingernails. And then something happened.